Hi students, in this video we're going to deal about the projection of planes. So in the previous videos I explained how the projection of points and projection of laminas will be done. So coming on to the projection of lamina. So what do you mean by plane? You have to define first. A plane is nothing but a two-dimensional object. So it is having only the length and the breadth, and the thickness will be neglected. So if you take any of the solids where I want to consider three-dimensional length into breadth into height, so there if the height is completely negligible, then we can call that one as a plane or a surface or a lamina. So the various shapes we're going to deal in this syllabus are the square, rectangle, circle, pentagon, hexagon, as well as the triangle. So what are the different types of planes we're going to deal? So there are two types based on the position of the planes. So if a plane as is having a surface perpendicular to any of the reference planes and parallel to another reference plane, then we call that one as a perpendicular plane. If the plane is having their surfaces inclined to both the reference planes, then we're going to call that one as an oblique plane. How exactly we are going to define the position of the plane? If you take the lines, we already defined how exactly the line will be having the positions with respect to HP and VP. Similarly, we are going to define in the planes also. The first type will be the position will be surface of the plane kept perpendicular to HP and parallel to VP. Second one will be perpendicular to VP, parallel to HP. Third one, perpendicular to both the HP and VP. The fourth one, kept inclined to HP and perpendicular to VP. And fifth one, inclined to VP, perpendicular to HP. And the last one will be inclined to both HP and VP. So how exactly the projection will be done? So projection will be done based on the change of position method. So where if a surface is inclined to one reference plane, will be drawn by the changing the position of the plane surface from the simple position to a required position. So in this we will have a two stage or three stage. So this process is called as change of position method. If you take the three stages, so what are the three stages involved here? Is the first one is the simple position. So simple position is the nothing but initial position based on the given condition. You're going to start the projection. The simple condition can either be, so you're going to take the lamina. If I take the lamina over there, so this is the lamina. If the lamina is parallel to HP, so I can't see the actual size of the lamina and I'm going to observe from the front. So what I have to do is I have to observe from the top. When I'm going to observe from the top, I can see the complete true shape and size of the lamina. So I'm going to start my projection from the top. If the surface is inclined to it is parallel to vertical plane means I can't see the actual length and size from the top view. So I can see only the one edge. So when I go and observe from the front, I can see the complete size and shape of the lamina. So directly I can draw the projection from the front view. So I want to start my projection from the front and I want to project that into the top. The second position will be with respect to the surface of the lamina. If I am going to keep that like this is the surface of the lamina, so which is kept on the HP now. If I go on to incline this HP, that will be your second position. That is the surface is inclined to HP. Similarly, when it is parallel to VP, I want to rotate with respect to VP. The surface of the lamina is inclined to VP, so that will be the second position. When you go for third position, it is purely based on the condition they are going to provide. So the condition will be either the edge or a diagonal or a perpendicular bisector will be inclined to the HP or VP based on the condition they provided. So that will be the final position and that gives the actual view of the lamina. So when I go for next one, we are going to see the each condition how exactly it's going to look. So the first condition I am going to consider is a plane perpendicular to HP and parallel to VP. So when I am going to take that, so you can see from the sketch the lamina ABCD is parallel to VP and perpendicular to HP. So when I want to observe from the front, I can see the complete shape of the lamina that can be projected directly onto the vertical plane. So I want to get all the dimensions exactly and I want to name that one as A dash, B dash, C dash and D dash. That will be your front view on the vertical plane. But when I want to observe from the top, I can observe only one of the edge, that is AB, whereas CD will be invisible, it is behind. BC also invisible and AD also invisible. That's why when I want to draw the top view, I can draw only one edge over here and AB will be visible, that I want to specify. So below A we have D, that will be invisible, and below B we have C, that will be invisible. And this distance can be taken based on the condition provided. If they are not specified in the problem, you can assume the distance. So maximum number of times in the projection, they're going to see either it is resting on HP or VP. So that will be the condition they're going to get. So coming on to the second condition, when the plane is perpendicular to VP, parallel to HP. So when I want to observe from this, I can see that ABCD lamina, it is parallel to HP and perpendicular to VP. So when I want to observe from the front, I can see only AB line, whereas CD line will be invisible, AD will be invisible, and BC will be invisible. So I want to write the front view as only A dash and B dash, whereas D and C will be in the bracket, so it shows they are invisible. And when I want to observe from the top, I can see both AB, all the points, that is ABC will be viewed. I want to do. So I want to start my projection from the top view, then I want to project onto the front view in this case. Whereas previously I want to start from the front view, then I want to project that into the top view. So coming to third condition, when plane is perpendicular to both VP and HP. So in this case, when you want to see this condition over there, ABCD is the plane which is perpendicular to VP as well as perpendicular to HP. So in this case, it will be parallel to profile plane. So from side view only, I can see the actual size and view of the lamina. Whereas when I want to observe from the front, I can see AB. When I want to observe from the top, I can see D and A. So you can see over there, I can start the projection from the side view itself. But when I want to start from here, I can see the front view as AB, that will be specified over there, and D and C will be invisible. When I want to observe from the top, AD will be near to the observer, that I want to write as D and C, and B and C will be invisible. This is the third condition. Coming to fourth condition, a plane is inclined to HP and perpendicular to VP. So you can see over there, the plane ABCD is inclined to HP with an angle of theta, and it is perpendicular to VP. So when I want to observe from the front, I can see what is the length of this one AB and the inclination. So that can be directly projected over here. So in this case, I can't directly start from the top view because I don't know what is the angle and what is the true length of any of the side. So I want to start from the front view. Sorry, that is from the front view. I want to write AB at an angle theta. Then I want to project the points onto this where I can see the BC length for the actual. So that will be known, that is BC length will be knowing. So I want to know this side. I want to directly project the points. So that is how we are going to construct. When coming on to the next condition, a plane inclined to VP and perpendicular to HP. So in this case, the plane is kept like this, where it is inclined to VP with an angle of pi. So when I go, sorry, angle of theta, and it is inclined. So what I'm going to do is, when I want to go for this inclination I can see from the top view. So I can see the values from the top view, whereas from the front view I can see only the distance between A and B, that will be projected over there. So A and B will be projected onto vertical plane, and this I want to start from the top view, where I want to know the angle pi and the true length of A and B. So I want to draw this. I'm going to project for the front view, and I'm going to get the shape of a lamina. So this is the fifth condition. Coming on the sixth condition. So sixth condition is the way it is inclined to both the reference planes. So here drawing both the views will give me the apparent length of the lamina. So this is one where I want to combine all the three stages. I want to start my initial position, second position, then I'll go for third position. So initial position is, I want to assume it is parallel to either HP or VP. I want to project for the view. Then I want to incline the surface of the lamina either with respect to HP or VP. Then I'll come back to the last condition where it is inclined to either VP or HP. So here I want to get initial position, second position, and third position. So all three positions will be drawn to get the actual view of the lamina. So the problems we are going to see in the next video.